Good morning. This is for your exercise that's dated for the 20th of April 2020. Welcome back to Honors Chemistry. I hope everybody stayed safe during your spring break. Your worksheet's going to look like this. You're going to have 10 calculations to do. I'm going to go through one example for you. But the first thing you're going to have to do is get down the definition for molarity. It'll be something new we have to calculate today. I'm going to be giving you the formula for molarity. And then we'll also determine the number of particles besides the other questions, because what we're going to be doing for this today is, for example, you're going to have balance the chemical equation, determine the type of chemical reaction, write the equilibrium chemical formula, and determine the molarity calculation. The molarity calculation has two parts: the actual calculation for the molarity and the calculation for the number of particles. So let's go and get started. I'm going to have one example I'm going to go through with you, okay? So what I want you to do is everyone get down the definition of molarity. Molarity is used to express the concentration of a solution. It's also known as molar concentration. The what is in blue is what's the most important that you need to remember. Molarity is the number of moles of solute. Remember, that's like the stuff that's dissolved in something per the liter of solution. So molarity is the number of moles of solute per liter of solution. Make sure you get that down. I'll give you about a minute, not even a minute. I'll give you 30 more seconds. Molarity is used to express the concentration of a solution, also known as molar concentration. At least get this blue down. Molarity is the number of moles of solute, the material dissolved, per liter of solution. Just about that time. A few more seconds. Now you want to know what the formula is for molarity. Molarity is a new calculation, like I said, we have not used before. So what you need to do is go to your chemistry reference table and go to page, the formula pages. Let's find a formula page for that. Not that front page, the second page, third page. There we go. Here we go. Molarity. Molarity, which is capital M, equals the number of moles of solute divided by the liters of solution. This is what you need to write down for the formula for molarity. Capital M equals moles of solute divided by the liters of solution. And I provided a line for you there if you want to use that. Well, go ahead and get your line. I did not provide a line. I have something else. But molarity equals the moles of solute divided by the liters of solution. Hopefully everyone got that. Now let's go to the very front page of your reference table. Front page of your reference table. Now you're talking about the number of particles. Hopefully we remember this. We covered this before. But if not, we're okay. Life is still good. Oops. I'm trying to get to the top of this. Go to the very top of your page, of your reference table, very front page. Avogadro's number. Some people like to call it Avogadro's number or Avogadro's mother, but it's not. It's Avogadro's number. And for the North Carolina, they round it to 6.022 times 10 to the 23rd particles per mole. So what I would like for you to do, and it says number of particles, write down Avogadro's number. Write the word down, Avogadro's number. Yeah, Avogadro's number. Because you'll need to recognize this number is talking about Avogadro's number. If they say Avogadro's number, you need to know, hey, I need to go find it on my reference table. You don't have to memorize it. Then I want you to put this value down. Avogadro's number is 6.022 times 10 to the 23rd particles per mole. 6.022 times 10 to the 23rd particles per mole. Get that down. Okay, now that we've got this done, now what I want you to do is I want you to go to this, we filled this out. I just kind of gave you another example of that real quick. Okay, so we've got, this is on your sheet. You wrote your formula down, you wrote the number of particles. Now I'm going to go through an example for you. On your question, this is not, I did not work any of these for you. I just pulled one up to do it as an example, so you'll have to do all 10 of those yourself. It says balance the following chemical equation. This one I already balanced for you. So it has 2 aluminum bromides plus 3 chlorine gases yields 2 moles of aluminum chloride plus 3 bromines. This is already balanced. If you don't remember how to balance chemical equations, you need to go back to the lessons we covered. We had about 5 or 6 lessons on those, so please refer to those. Then it says the type of chemical reaction. Ooh, I should not have deleted that. There, that's all right, we'll get it. The type of chemical reaction. Some of y'all had a mistake there. You were either Googling off of the, to get your answers off the internet, or you were copying off each other and got it wrong, okay? You do not copy off of people. You need to learn this stuff. When you get to college chemistry, they're going to expect you to know this, okay? So don't come in here and pretend, hey, we didn't cover that. We did cover it. But if you've been cheating off of somebody else or you're getting it off the internet, then you did not get it yourself. Okay, now you go to the types of chemical reactions. This is where I found out that people were either Googling it, trying to get their answers, or you were copying off of someone else, because over half the class had this wrong. So what you need to do is go to your reference table. I think it's page 6. We've covered in detail the solubility rules. But go down to the bottom of that. It says guidelines. Guidelines for predicting the products of selected types of chemical reactions. Types of chemical reactions. These are your choices in North Carolina. No combinations there. For some reason, instead of synthesis, half the class put down combination. This is not a combination reaction in North Carolina. It's a synthesis. Synthesis equals small plus small is big. Decomposition is a big, breaks down to a small and a small. Single replacement is when you have we've already eliminated the other types. You've eliminated the synthesis and decomposition, but you have a single replacement. It means you've got some single element on the right-hand side. Single element on the right-hand side. In this case, single element on the right-hand side. Double replacement, you do not have a single element. And combustion must have the hydrocarbon and the oxygen. Hydrocarbon and oxygen. And yields carbon dioxide and water. It has to have those. If it doesn't have those, it's not a combination. Those are the ones you need to choose from. The only ones: synthesis, decomposition, single replacement, double replacement, and combustion. That's what the state of North Carolina gave you. Now let's go ahead and get started with the answer the questions then. On our sheet, you have the balanced chemical equation, type of chemical reaction. You see you have a single element over here. It's not small plus small is big. It's not a big, break it down to small. There's no oxygen gas, so you can eliminate all those. And there's a single element. So this one has to be single replacement. Single replacement. Then you go to the, you're trying to do the equilibrium chemical equation. Whoops. Bracket, 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 bracket. Here you take your products on the top. And then with this here, you have to take, since you have 2 of those, you have to take the superscript, put 2 there. Your other product is Br2, bromine. And you have 3 of those. Then you take your reactants, bracket, two of those. And chlorine gas. and you have 3 of those. So there's your equilibrium chemical equation. Then you have to come up with the number of grams and the number of particles. The number of particles is first of all, you go for the number of grams. Okay, first of all, you have the molarity. Molarity equals the moles of known divided by the liters solution. So molarity, we already have that calculated. It's 0.25 equals the moles of solution. That's what you're looking for. Divided by, and it gave you 1200. Therefore, you've got 0.25 times 1200 equals 300 moles of known. So that you've got 300 moles of the known. So how do you come up with the number of moles of the unknown? You take your number of moles of your known, times it by the, so the known here is bromine. You have 3, you take your, you're looking for how many did it use of this. So you take the coefficient of your unknown divided by the coefficient of your known, times 2 over 3 equals 200 moles of your unknown. And paste. And we know how to do the molar mass. Hopefully you know how to do the molar mass. Molar mass, you take your aluminum, which is 26.98 plus 35.45 times 3. And that equals a total of 133.33 grams per mole. But you don't have just 1 mole. You have 300 moles, 200 moles rather. Because you're talking about the unknown times 200. So 133.33 times 200 equals 26,666. I don't like that number, but we'll just go with it. That many grams, okay? You've got that many grams. So all you have to do now is remember the moles. 200 moles is what you're looking for. So you need to know how many particles you have. If you have 200 moles of what you're looking for, all you have to do is multiply Avogadro's number, 6.022 times 10 to the 23rd. Oops. 23rd, and that's going to come up to your number of particles. So that comes up to 1204.4 times 10 to the 23rd. Let me fix this. Sorry, I'm going slow here. I'm trying to hurry so I won't run out of time. My video's time's about up. So to 10 to 23rd, you have to move the decimal point over 3 spaces, 1.204 times 10 to the 26th particles. This is 23rd. Because you move it over 1, 2, 3, you have to add 3 to the exponents. 23 plus 3, that's going to have to the 26th. So there you go. There's the answer. So you already figured out how to do the other parts. Now you know how to do the molarity, and you know how to do the number of particles. So good luck with your work today, and make sure you get this turned in by 4 o'clock today. You should not be turning it in at midnight. Please don't turn it in late, okay? Turn it in on time. I hope everybody stays safe and try to stay as happy as you can. Remember, if you have extra time, read a good book. That makes it happy. So anyway, it makes it good. Anyway, y'all take care, and remember, you've got a lot of things to be thankful for. Y'all take care, and I will see you then tomorrow with a new lesson. Thanks again. Take care.